Friends, today I am now going to discuss the properties of Fourier transformation. In the previous video, I have discussed Fourier transformation introduction. Now I will discuss very quickly and in very detail the properties of Fourier transformation. Properties of Fourier transformation. Properties of Fourier transformation. So let's discuss it. What are the properties of Fourier transformation? Actually, the properties of Fourier transformation is such that, suppose property number 1, linearity theorem. Linearity theorem. First property is such that if you have a function such as f of x equals c1 f1 of x plus c2 f2 of x, this type of function. If you have function f of x equals c1 f1 of x plus c2 f2 of x, so what you will do now? So the Fourier transformation of this function will be such that Fourier transformation of that function will be c1 into Fourier transformation of f1 of x plus c2 into Fourier transformation of f2 of x. Means if you have a function in such way c1 f of 1x, c1 f1 of x, c1 f1 plus c2 f2. So Fourier transformation is just, it will be such that c1 f of f1 plus c2 f of f2. Just keeping the constant outside and doing the Fourier transformation of that function in position space. Second property is change of scale property. Change of scale property. Change of scale property. What is the change of scale property of Fourier transformation? Change of scale property means, I will discuss the example with it also, so don't worry. Suppose if we have a function such that f of x, and the Fourier transformation of that function is f of x equals f of k. In k space Fourier transformation is being occurred. So if f of x, here x is replaced by ax, if f of x is replaced by f of ax, so what will be the Fourier transformation of f of ax? So Fourier transformation of f of ax will be 1 by a Fourier transformation of k by a. This is the property 2. That means if a function is such that a multiplicative constant is multiplied with that f of ax, and if we do Fourier transformation of that 1 by a f of k by a. So this is the change of scale property. Scale is changed. Change of scale property of that Fourier transformation. So let's discuss third property. Third property is what? Shifting property. Shifting property. Shifting property. So what is actually shifting property? If we have a function f of x such that Fourier transformation of function is described as f of k. So what will be the Fourier transformation of, if the function f of x is changed to f of x plus minus a? If the function f of x is changed to f of x plus minus a, so Fourier transformation of f of x plus minus a will be what? It will be e to the power minus plus e to the power iota k. Remember it, not plus minus. It will be minus plus e to the power minus plus iota k f of k. That means what? If we do the Fourier transformation of f of x plus a, then we will get e to the power minus iota k f of k. Okay. And if we do Fourier transformation of f of x minus a, we will get e to the power plus iota k of a f of k. So that's a shifting property. So let's discuss an example also. Suppose we have a function f of x. Let me change the pen color actually. suppose we have a function f of x, okay, and suppose we are taking the function e to the power iota ax f of x, e to the power iota ax f of x. So what will be that? Fourier transformation of this thing, Fourier transformation of e to the power iota ax f of x will be, so what will be the Fourier transformation of e to the power iota x f of x? So Fourier transformation of, it is actually not example, sorry, it's also a property, and property that consequence of previous property, that f of x plus minus a. So Fourier transformation of e to the power iota x f of x is, e to the power iota x f of x will be f of k plus a. How this is a consequence of previous property? Actually, whenever from the Fourier transformation of f of x plus a we are doing it, we are getting what? We were getting e to the power plus minus iota k f of k, okay. But whenever Fourier transformation of, likely we are doing inverse Fourier transformation, we have not discussed about that, but I am telling you the property actually. Similarly, if we do the opposite thing, f of e to the power iota ax f of x, e to the power iota x f of x, so Fourier transformation will be what? Fourier transformation of e to the power iota x f of x will be f of k plus a. It is also a shifting property, so note it down. E to the power iota x f of x will be f of k plus a. Similarly, another shifting property is e to the power minus iota ax f of x, if it is a function, suppose phi of x. So Fourier transformation of phi of x will be what? E to the power minus iota x f of x. So Fourier transformation of it will be f of k minus a. Okay. So let us discuss another property. Another property of the Fourier transformation is modulation theorem. Modulation theorem. So what will be the modulation theorem? Modulation theorem is such that, suppose that thing means if you have a function f of x and the Fourier transformation of f of x is f of k, okay. So now if the f of x is modulated by f of x cos x, such as f of x e to the power iota x that we have discussed, so how can you will describe it? So Fourier transformation of f of x cos of x, it will be half of f of k plus a plus f of k minus a. How we can write that? Because we know that cos of x equals what? Cos of x equals, cos of ax equals what? Cos of ax equals e to the power iota x plus e to the power minus iota x divided by 2. So if we do f of x cos of ax, so it will give you, now what you know? You have already known that f of x e to the power iota ax, what it will give? It will give Fourier transformation f of k plus a. So whenever you are doing f of x cos of ax, so what you are doing that? It means Fourier transformation of f of x e to the power iota x e to the power minus iota x divided by 2. So now what it let me write with changing the pen color. So this part, Fourier transformation of this part, f of x e to the power iota x, what it will give? It will give as f of k plus a. And let us change also the pen color now. F of x e to the power minus iota x, it will give, what it will give? It will give f of k minus a. So we can write the modulation theorem as, let me change the pen color again. So we can write the modulation theorem in such a way: f of x cos of x equals half of f of k plus a. Let me write clearly, sorry. F of x cos of ax equals half of f of k plus a plus half of f of k minus a. So this is the modulation theorem. This is another property. Now one of the most important property I am going to discuss, the Fourier transformation of x to the power n. Fourier transformation of x to the power n f of x. Fourier transformation of x to the power n f of x. The property of it, it is the result of it will be, let me write, minus iota whole to the power n dn dxn ddn dxn, sorry, not dx, not x, because we are changing it into the k space, dn dkn f of k. Suppose similarly, again write this property x to the power n f of x, it will be minus 1 whole to the power n dn dkn f of k. Suppose we are doing Fourier transformation of x f of x. Okay, so Fourier transformation of f x into f of x, what it will give? It will give minus I whole to the power 1 ddk fk. Yeah, similarly, so what we can write, f of x fx equals minus iota dfk by dk. It is one of the most important property. Similarly, from this property we can write another property, Fourier transformation of integration a to x f of x dx. It will be written as such that f of k minus iota k. This is another important property. This function is known as phi of k. So this is another important property that we are now discussing. So another important thing is Fourier sine transformation. So what do you mean by Fourier sine transformation? So formula for Fourier sine transformation will be, formula for Fourier sine transformation will be such that f of s fx, it will be root over 2 by pi integration 0 to infinity f of x sine kx dx. So similarly, Fourier cosine transform can be written as root over 2 by pi integration 0 to infinity f of x cos kx dx. So similarly, another some important integration result you should know in case of Fourier transformation. Some important integration result from the Fourier transformation you should know, that is integration 0 to infinite sine ax by x equals pi by 2 integration 0 to infinite e to the power minus x square dx equals root pi by 2. It will be helpful for doing Fourier transformation during the Fourier transformation question. Another important property, now we will discuss that, Fourier transformation of Dirac delta function, what it will represent. Important property, write down that Fourier transformation of Dirac delta. What it is representing? Fourier transformation of Dirac delta. Dirac delta function is what? Actually, Dirac delta function, it is such that f of x equals delta x minus a. Okay. Now, if we do the Dirac delta function such that delta x minus a means what? At x equals a, it is infinite, otherwise 0. It's representing at x equals a, it will goes to infinite, and otherwise it will be 0. This is a case of these actually Fourier Dirac delta function. So suppose you have a function delta of x minus a, and now you are doing the Fourier transformation of it. What you will get? Fourier transformation of Dirac delta function. So let's do the Dirac delta function, Fourier transformation of Dirac delta function. So Fourier transformation of Dirac delta function, it will give actually 1 by root 2 pi integration minus infinite to plus infinite delta x minus a to the power iota kx. Let me write properly. To the power iota kx dx. So it will give 1 by root 2 pi to the power iota k. Now just imagine the result. Fourier transformation of Dirac delta function is giving you what? Oscillatory plane wave function. Oscillatory plane wave solution. So Fourier transformation, write this property also. Fourier transformation of Dirac delta property, Dirac delta function will give you oscillatory plane wave solution to the power iota k. So that's it for now. We will discuss the most important part, that is convolution theorem and Parseval's identity. Convolution theorem and Parseval's identity, and most importantly problems on Fourier transformation in the next part of the video. So that's it for now. Thank you so much for patiently watching my video. Bye.